Hi friends, in the last videos we have discussed the chain rule of differentiation for vector fields. We have seen the conditions there for the differentiability of first function at the domain point and differentiability of second function at the codomain point of the first function and all that. Then we have finally seen that the composition map can be differentiated at the corresponding point. Now today we will verify that theorem. That rule, chain rule of differentiation, we will verify with the help of this very example. This example will also tell you how to calculate the total derivative of a function at a point, total derivative of vector field at a point. You know, that's actually the matrix having order dimension of the codomain space times the dimension of domain space. So we will verify that. We will also see the total derivative for these vector fields also, how to calculate these at a given point. I will choose this example. I suppose G is from R square to R cube given by this one. I write it as vector form here, G1 to G3. So our G1 is root of x, G2 is square root of x square plus 3y square, and G3 is y plus 2. Similarly, f is from r cube to r square, given by f is f1, f2, where f1 is this function, f2 is this function. Now, g is from r square to r3 and f is from r3 to r square. You will have a composition f operation g that will be from r square to r square. So, I suppose the point is point A in r square is a comma minus 1. Then you know we take the corresponding point for function f as b, which is the image of that very a, image of a under the function g. You can substitute here a is 1 minus 1. When we substitute it in the function, we get 1, 2, and is minus 1, it's 1. And I suppose h is the function f operation g. This is the composition map. Then the rule says us actually this holds. This holds. We will verify this rule today. So first of all, we will find the value of f dash b and f g dash of a, and then we will also find the value of h dash a. For that value, we will directly first find the composition map h, then find its total derivative. In this case, you have to find the total derivative of f, total derivative of g, then take the corresponding composition. Since these are matrices, you have to multiply the corresponding matrices. In this one, we will first find the value of h as a composition of two functions, then we will find its corresponding matrix representation. Okay, let us start the solution. You know the total derivative of g at A is actually the Jacobian, or you can say a matrix whose entries are actually the partial derivatives of the components of G. Your G is here, this one. So I can say G dash of any x, y, z. First I will take what x, y, z, G dash x, y. I will take any point, then I will substitute the value 1 and minus 1. You know the entries of this G dash, this is a matrix, its order will be 3 cross 2. So you will have 3 rows and 2 columns. There will be 2 columns. In the first row, there are the partial derivatives of first components of G. G is G1, G2, G3. So the first component is G1. So along the first row, you will have the partial derivatives of G1. So you will have del G1 by del X, del G1 by del Y. Similarly, second is del G2 by del X, del G2 by del Y, then del G3 by del X, del G3 by del Y. This is 3 cross 2 matrix. Now what are the values? You can find the partial derivatives. G1 here is this function. So its derivative is 1 by 2 root x. Then partial derivative of the same function. It is the function G1. G1 is square root of x. It's two partial derivatives. So second will be 0 because it is independent of y. Then the function G2, that is this function, its partial derivative with respect to x will be 1 by twice under root of x square plus 3 y square 2x. 2 will go. So it will be x over x square plus 3 y square. Square root of this one. Then the derivative with respect to y will be same but 3 multiple. So 3y over under root of x square plus y square. Then the last is only the function of y, so it will be 0 here. Then it will be 1 over 2 times square root of y plus 2. Before this, you should note that these functions are differentiable functions because their components are this square root x, this one, and the point is 1 minus 2. You can see all the partial derivatives of these components are continuous at the point 1 comma minus 2. In fact, there is a result which says if the partial derivatives are continuous, all the partial derivatives are continuous at a point, then the function is differentiable at that point. So the partial derivative of all the partial derivative of the first component G1, that is square root of x, it has two partial derivatives. One is this one, second is this one. Both this is continuous at point 1 comma minus 1, this is continuous at 1 minus 1. So this is differentiable. Similarly, you can see this is differentiable, means the function g is differentiable. In a similar way, you can see f is differentiable at the point 1 to 1. So I can use the chain rule. Now let's calculate the value of g dash at a. So what is g dash a? Therefore g dash of a, that is equal to g dash of 1 minus 1. That you have to substitute in this one. X is 1, y is minus 1. So x is 1, it is 1 by 2. Y is minus 1, here it is 0. X is 1, here you have 1 minus 1, so it is 1. 3, that's 4, that's 2, so it is 1 by 2. Then minus of 3, it's here 3y square. Again 2. Then 0, and this would be 1 by 2. Because when you substitute minus 1, so it will be 1 by 2. So this is our g dash of a. G dash a is this quantity. Now let us find f dash of f dash. I will put this g dash here. The value of g dash is 1 by 2, 0, 1 by 2, minus 3 by 2, 0, 1 by 2. This is our g dash. Now let's find the value of f dash. F dash again is here a differentiable function because it's a function from 3 variables. We have to take the partial derivatives of its components with respect to 3 variables. And now in this case you have f function from R3 to R square. So its total derivative will be a matrix of order 2 cross 3. Its order will be 2 cross 3. So you will have in the first row the partial derivatives of f1, that is del f1 by del x, del f1 by del y, and del f1 by del z, because in this case you have 3 variables. Next is del f2 by del x, del f2 by del y, del f2 by del z. To get the values of these partial derivatives, you can calculate from their corresponding values. F1 has this value, So partial derivative is 2x. The first partial derivative with respect to x, with respect to y is 2y, with respect to z is 4z. Then with respect to x is twice x here, minus twice y here, and 0 here. This will imply f dash at the point b, because f dash we have to evaluate at b. So this is f dash of, what is b here? Our b is 1 to 1. To evaluate this one, substitute the values here. So x is 1, so this is 2 along the column. Y is 2, it is 4 minus 4. And last will be 4 0. 4 0. So this is our f dash b. We will calculate first of all the right hand side. Now I will find the value of the product here, f dash b operation g dash a. Now it's confirmed here because these are the matrices now. This composition will be actually the product of matrices. So what is the value of f dash b? Now, f dash of b operation g dash of a will be equal to f dash b is 2, 4, 4. I'll write like this because g dash is given to me here. So it will be here like this. Value of f dash is 2, 4 and 4, 2 minus 4 and 0. Now I have to multiply these two to get the value of right hand side. The value of right hand side is the product of these two. So composition here is simply the matrix multiplication. Here this is 2 cross 3 and this is 3 cross 2. So product is well defined. You can calculate the product of these two, that is 1 plus 2. Sorry, this is this row into this one. Yes, it is 1 plus 2. Then this with this one is minus 12 by 2 is minus 6. Then plus 2. Then here along this one it is 1 minus 2. And the last element is 12, that is 6. So this equals to 3 minus 4 minus 1 and 6. Very simple. So this is the value of f dash b operation g dash a. The value of this. Now I will calculate the value of h dash a. And it was actually understood that this composition actually is from R square to R square. Corresponding matrix must be 2 cross 2. That's the value here. Now let me write this here. Value f dash b operation g dash a is this. Now I will calculate the composition of f and g. Now, what is the function h? The function h is actually f operation g. So I can say here, let me write like this. Of course, h will be a function from R square to R square. So only of two variables I will use the point xy here. So I have h is actually f operation g of xy. By definition of composition, it is f of g of xy. Now g is given to us, that is f of, what is the value of g? Root x x square plus y square, 3y square, and square root of y plus 2. This is the value of f. Value of, not f, but of g here. Now, f is given to be this function. F takes x, y, z to this one. So, what is f of this? This will be equal to, you just treat this as x, this as y, and this as z. This is x, this is y, this is z. When we substitute, actually here you can write, it's here f of x, y, z. For x, y, z, it is x square plus y square plus 2yz square, comma, x square minus y square. So here you will have sum of the squares. It will be x plus x square plus 3y square, then plus 2yz square, that is 2y plus 4, 2z square. Then the next is x square minus y square. So you will have this square minus this square, that is x minus x square minus 3y square. Or, okay, this is the function h. Now we find the derivative of this h dash. We will calculate the derivative of h dash. I mean this h. We will calculate h dash for h. That will be h dash of xy at the general point. Again we have two components here. This is the first component, this is the second component. So along first row, the partial derivatives of this with respect to x is the first one, that's 1 plus 2x. With respect to y will be 6y plus 2. Then with respect to x is 1 minus 2x, with respect to y is minus 6y. Minus 6y. Now you have to calculate h dash of a. A is given to be 1 comma minus 1. So what is h dash of? Now h dash of a is h dash of 1 minus 1, which is equal to, substitute the values here. X is 1, so this is 3. Y is minus 1, so this is minus 4. X is 1, so this is minus 1. Y is minus 1, this is 6. Exactly this one. F dash, operation G dash. So you can say this implies h dash of A is equal to f dash of B operation G dash of A. Hence the rule is verified. Hence the rule is verified. Very simple example which helps us to understand that how all the things goes in the proof.